Chapter 12, Example 4. Now that your experiment is properly designed, you set out to buy tomato plants. Your normal supplier has only 18 plants available, so you purchase 6 more from a local garden center. Since the plants come from different sources, it is possible that they were cared for differently. Redesign your experiment to account for this. Okay, so now I'm going to redesign it. Now, they could be cared for differently, like it says. Perhaps they're grown in different soil. Maybe one store already gave the plant some fertilizer, so that could impact it. So the easiest way to account for this is to use blocking. I'm basically going to do 2 different experiments. I'm going to experiment with the first 18 plants, and then with the 6 from the other store, from the new store. So for simplicity's sake, we're just going to look at this from the whole basic setup with all the extra factors and conditions added. Okay, so we have 18 tomato plants. We're going to randomly assign them 9 per each group. Group 1 will have 9 plants. Group 2 will have 9. Group 1 will lead to treatment 1, which is our control. Okay, treatment 2 will have the full fertilizer, and then we will compare that group for juiciness and tastiness. Then with our remaining 6 plants, we're going to essentially conduct another experiment. Okay, so I'll randomly assign those into 2 groups. Group 1 now has 3 plants, Group 2 has 3 plants, and we'll give Group 1 the first treatment. We'll give Group 2 the second treatment, which is full fertilizer, compare juiciness and tastiness. We don't want to compare the groups to each other because we think there's some fundamental difference between them. Okay, and of course we want to write this up, write up our steps. Okay, so since I want to conduct the experiment with 24 tomato plants, but can only acquire 18 from a normal supplier, I'll purchase 6 additional plants from a different source. It's likely that those plants from different suppliers will be different in some way. Different strains, grown with different methods, whatever. I will block by plant suppliers. That's what I'm blocking by. Okay? Block 1 will consist of 18 plants from my normal supplier. Block 2 will consist of 6 plants from an alternate source. Each block will have 1 factor, fertilizer, and 2 levels. No fertilizer and the recommended amount. This will result in 2 treatments to which the plants will be randomly assigned. Don't forget the importance of the random assignment. The plants from the usual supplier will be numbered 1 through 18, and random numbers will be generated by technology. The first 9 unique numbers will indicate corresponding plants be assigned to treatment 1, the control group. Now that unique number is important because that tells us that we're going to ignore repeats. Okay, the remaining 9 plants will be assigned to treatment 2. The assignment procedure will then be repeated for plants 6 from the alternate vendor. Okay, I will grow the plants near each other in similar soil, amounts of rain, sun, similar temperatures. When they've reached full maturity, I will harvest them and store them for evaluation. Each block will be individually assessed. We will not need to compare the blocks to each other. Okay, so that adds a little thing to it. That's important that we don't have to compare them to each other, but also that means that that second block doesn't necessarily need to be under the same conditions. Every plant in that block needs to be under the same conditions. But, like, I can grow them block 1 in one greenhouse and block 2 in another if I need to for space or whatever. Okay, so each block will be individually evaluated within the block. And that concludes our example.